Hi everyone and welcome back to educator.com. I'm Dan Fullerton and in today's mini lesson we're going to talk about wave characteristics, specifically by going through page 1 of the A+ Physics worksheet on wave characteristics, which you can find the link for down below. Now again, note that these aren't AP level questions, but they'll test your basic understanding to see if we're at least in the ballpark of where we need to go. So let's dive into question 1. What is the wavelength of a 256 Hertz sound wave in air at standard temperature and pressure? And for this set of questions, we're going to be asked to assume that the velocity of sound in air at standard temperature and pressure is 331 meters per second. So what's the wavelength? Well, if V equals F lambda, then we know that lambda wavelength equals V over F, or 331 meters per second over 256 hertz, which will give us a value of about 1.29 meters. Answer number 2. Number 2, the graph below represents the relationship between wavelength and frequency of waves created by two students shaking the ends of a loose spring. Calculate the speed of the waves generated in the spring. Well, we have a couple different points we could use here, but all of these should follow our wave equation, V equals F lambda. So I can solve here for V by picking a couple points here. It looks like an easy point would be something like frequency of 1 hertz and a wavelength of 5 meters, which would be 5 meters per second. And if I did that at any other point here on the curve too, this would be 2 times 2.5 or 5. Or 2.5 times 2, or 5, or 5 times 1 again, 5. We have the same speed everywhere, which we should expect. So our speed must be 5 meters per second. Number 3, what is the period of a water wave if 4 complete waves pass a fixed point in 10 seconds? Well, period is the time it takes for one wave. So if we have 10 seconds for 4 waves, that would be 10 over 4, or 2.5 seconds per wave. Correct answer number 3. You could also do this by looking at frequency first. Frequency is the number of cycles per second, and if you go through 10 cycles or 4 waves over 10 seconds, you're going to get a frequency of 0.4 hertz. Then period is 1 over frequency, or 1 over 0.4 hertz, which again is 2.5 seconds. However you want to get there, 2.5 seconds is your best answer. Number 4, if the frequency of a periodic wave is doubled, the period of the wave will be, well, period is 1 over frequency. If you double the frequency, you've divided the right-hand side by 2, you have to take half the period. So the correct answer to 4 must be number 1. Number 5. If it didn't go so well, now would be a great time to go back and review wave characteristics. Thanks so much for your time, everyone, and have a great day.